Today, we'll be talking about rolling resistance. So we're going to be comparing the force that is required to move each of our trucks. And we're going to do this by taking into account rolling resistance. And rolling resistance is made up of the coefficient of rolling resistance for the tires of the car, and then the normal force on the tires. And rolling resistance is basically just a car term for static friction, and it measures the force required to move a car from a still position.
Okay, welcome back to our car show. Today we have a gray truck. It's got the V8 in it. Now it's got these Bridgestone tires on it. You see? These tires are round and they're gray. The gray keeps the heat out. Keeps them cool during the summertime. You see how smooth these ridges are? You got nice, good ridges to keep the water out, but they're not that deep to keep mud out. So you can have a lower roller resistance because they're smoother, less bumps, and you got more of the weight on the inside. It'll keep the weight down there in the middle by the heavy rim, and the outside tire rolls and stops smoothly and easily. This baby is my brand new 2020 Ram 1500 Laramie. See, she's got the Hemi 5.7, and she's got these big off-roading tires. Came with the 4x4 off-road package. So as you can see on the tires, they've got quite large ridges here. And they are Falken Wild Peak A/Ts. And they're a little bit larger, wider tires, so they come with a larger rolling resistance. The coefficient of rolling resistance is actually 0.93 compared to Nate's, which are 0.79.
Okay, so to find the rolling resistance, there's this formula that's provided. And so the formula is F equals Cn, and each of those letters actually means something. Yeah, so in the formula, F is the rolling resistance force, so that is the force against the car keeping it from rolling. And then C is the coefficient of rolling resistance, which is actually given by the companies who make the tires, so we don't have to work that out. And then N is the normal force, which is the force of the ground against the tires, which is essentially just the weight of the car times gravity. So using this formula, we can calculate the rolling resistance of each tire, and then we can use those numbers to compare the amount of force and efficiency of both sets of tires. And if you think this formula is familiar, it's because it is. It's the same thing as static friction, where F is the force of static friction, mu of S is the coefficient of static friction, and then N is the normal force, because rolling resistance is essentially static friction. For the first car, you're going to take the coefficient of rolling resistance, which is 0.79, and multiply it by the weight in the car in kilograms, which is 3,220, multiplied by the force of gravity, which is 9.81 meters per second. So you multiply the weight times gravity, you get 31,588 kilograms per second squared, and multiply that by the coefficient of rolling resistance, you get 24,955 newtons. And so for the second car with the rougher tires, fortunately the mass of both cars was exactly the same because they're the same class of truck. So the only difference is that the tires for this one had a much larger coefficient of rolling resistance with a value of 0.93. So the math that you use is exactly the same as before. You're going to do the coefficient of rolling resistance times the mass of the car, which is 3,220 kilograms, times gravitational acceleration, which is 9.81 meters per second squared. And so that all comes out to 29,377 newtons, which is about 4,000 newtons more than Nate's truck. The work and calculations we did has many implications in our modern society. For one, tire manufacturers can use this data to calculate ways to make tires more efficient, which would increase the fuel economy of modern gas cars, which would reduce our carbon emissions, which is always something good to reduce the amount of energy required to complete our daily tasks. Additionally, with electric vehicles, these calculations can be used to maximize efficiency, which is really important in increasing the range and versatility of new electric cars. Additionally, for things like semi-truck transportation and larger vehicles, this can be used to increase safety on our roads. and decrease the amount of downtime.
Although one of the major benefits of cars with lower coefficients of rolling resistance is that they require less force to move and so therefore less gas, there are many other advantages, such as these tires that require less force to move are also much better at lasting a long time. So we're not having to produce near as much petroleum so that we can make these new tires, because these tires will last longer.
Alright, so basically, even though these big off-road tires give the truck a nice mean look, they make it kind of a chick magnet. What I want you all to take out of this video is that they really do have a harmful effect on the environment. So when choosing tires, you're going to want to choose tires that have a low coefficient of rolling resistance so that you can help the environment. Big shout out to our physics teacher, Mr. Llewellyn. And if you learned something in this video, please leave a like down below or consider subscribing and leave a comment what was your favorite part. And thanks for watching.